So what I want to do is start with the basics. As we always do, and I say we don't assume that people have got prior knowledge. So I know there are a lot of students that have been watching these videos and probably will watch these videos. So what I want to bring into first of all is classifications of airspace, or more specifically the divisions of airspace. So here is a picture of the UK. Now first of all, I want to remind you is that airspace is country specific. Because it's Class A airspace here doesn't mean that it is Class A airspace somewhere else, and so different classifications of airspace change depending on what the country is. As pilot in command, it is for you to be aware of the airspace in which you are flying, be it classified or unclassified. But what you can see on that picture that I was showing you, and bear in mind so I can only really talk about UK airspace. I haven't spent too much time flying in other countries, so again, I'm going to keep it UK, certainly for those guys that are not, but there's a lot that is relevant, so I say you might just need to change the code. But let's try and do some form of country. I'm unhappy that that's kind of Britain. So, Britain is broken down primarily into 3 zones. And these zones, one comes up here, the other one is, where does that go? Comes through there. And so we get 3 distinct zones, 1, 2 and 3. Now, depending on what altitude we fly at, these kind of classifications change. The first that we need to be aware of is UIRs, or Upper Information Regions. Now, for a lot of you, and I would say 90% of you, it's completely irrelevant, because upper air regions start at flight level 195. It used to be considerably higher, but for some time now it's 195. In real money, that's 19,500 feet. There's not many of us that are going that high, and I'm sure if you're watching this and you spend a bit more. Now, the name of these UIRs is the same, and what we have here is London, Scottish, and Shannon. Now, why one's named after a town, one's named after a country, and one is named after a place, I'm not quite sure, but that's what they are. Below flight level 195, they are called FIRs, Flight Information Regions, and these will offer, unless they're too busy, some form of basic service should you request it, unless they're too busy, and then they might hand you off. So if you haven't already, I would recommend that you download this booklet, which is a free download. Just type in Skyway code. This is issue 2. And there is a lot of information in here. It kind of replaces what used to be the VFR flight guide. But one of the things that it does show you is those flight information region zones. Okay, so FIRs, UIRs. FIRs is probably the region, that's from the surface up to flight level 195. Now, there are also areas or altimeter setting regions. We won't go into those too much because they aren't really airspace, they are regions. But you can also get what's called LARs. I mentioned these before, and these are lower airspace radar service, and they pretty much cover the entire of the country. Normally they are military sites or associated with a military base where there is lots of people working the radar traffic, and again they will offer you some form of basic service should you be on RT. And other things that we also get are frequency monitoring codes. Now all of these are in that book, it's no secret, it's just there for you to read, so a very useful book to have. Now When we're flying in these FIRs, it's further broken down into classifications, and these can be, well, in our country, A, C, D, E, F, questionable, and G. Now, when I first started flying, B was an airspace, and certainly F was around, and now E. Well, we'll come on to that one, but again, we normally associate the lower the letter, so A, with higher classification airspace, and D, maybe not so bad. But if you were to enter airspace without permission, the ROTH would still be just as bad. Now, another useful download is this one. This is the CAA, let me get this right, UK ATS Airspace Classification. Now, if you type that in Google, it will give you a PDF, and it's a really nice download to have. Can you see that now? Now, this one's slightly out of date because the one that you now get download, F has been blotted out. And what this will do is it will tell you what is and isn't permitted in that particular airspace. Now, bear with me. If you go to page 61, if you're not already there, you'll again see this information: Class A airspace and what it looks like, Class C airspace, Class D airspace, Class E airspace, and Class G airspace. So this book is current. Now, let's try and bring those into us. So we've already said that we have Class A airspace. We might as well put it on Class B airspace, C, D, E, F, and G. So they are the available ones. Now, first of all, B used to be, or C used to be B. So B is yet to be classified. So Class B airspace is no use to us. And Class F, I think there might still be one transit zone down south, but at the minute Class F is no longer useful, is available as well. So this line here is all the uncontrolled, and A through to D is all controlled airspace. So pretty much in most flying fields when we take off, we're going to be flying in Class G airspace. Now, in Class A airspace, there is no VFR traffic permitted. You can get SVFR, we're not going to go into SVFR today, but you can possibly request permission to transit through Class A airspace. The likelihood is that they're going to say no, but it's certainly possible, and certainly with a lot of airspace changing of late, more airspace is sort of blotting zones, and so the BMAA are, certainly for microlighters, doing what they can in order to keep airspace open. Now, Class C airspace is above flight level 195. Now again, that's pretty much the UIRs, the upper information regions, and again, of no use to us whatsoever unless we're going to go above flight level 195, which is highly unlikely, so Class C is of no relevance to us either. Class D airspace, we would normally find major CTAs and CTRs. Now I'll come on to CTAs. Pretty much most of your major aerodromes, so East Midlands, I think Manchester and Liverpool, are surrounded by Class D airspace. It's only when you get Class A airspace for major CTAs, airfields like Heathrow, airfields like Gatwick, where they really want to be in control of every single movement within the area. Class E airspace, there is Class E airspace, you've really got to hunt to find it, and it tends to be in Scotland, particularly surrounding Glasgow and Edinburgh airfields. The thing about Class E airspace is although you need permission to fly through it, you don't need to be on radio. So a little symbol they do is a headset with a microphone and a big cross through it. So really bizarre that we have controlled airspace, Class E. You do need permission to be in it, but you don't need to be on radio contact. What you'll need to do is give them an entry and exit point. You'll need to do this before you take off. And an entry and exit time. And obviously you'll be requested, once you land, to close, in effect, the flight plan to fly through it. Class G airspace, which is where most of us spend our time, is the unrestricted airspace. Now, a lot of people, when they first look at a navigation map, they see all of these lines and all of these varying points of airspace. And I remember when I first got my first map, I hadn't done much flying at the time, but I was keen, so I bought a map. I thought, where do we fly? The airspace is everywhere. Well, this is where we need to realise that airspace is not two-dimensional, it's three-dimensional. And yes, most of the UK is covered with some form of airspace, but it's at altitude, so it might be 10,000 feet. Well, unless we intend to go over 10,000 feet, is completely irrelevant to us. And one of the drawings that I found, or one of the pictures, I'm very pictorial, so bear with me. One of the pictures that I found very, very useful, if I can now find it, was in the Cosgrove book, which is obviously the microlight handbook. And it's very similar in most places, most textbooks that you get. Certainly on the Skyway Code, there is a very similar one. If I can find the picture, that would obviously be much better to have it prepared first hand. Welcome to Airways. I'm going to go for a third flick.
Talk amongst yourselves.
Talk amongst yourselves, yes. Don't forget, ask any questions. It's a small one, but you can see this one here, and it sets up the zones. Now I'm going to talk to you about these zones a little bit because they're quite important, and certainly being aware of these zones should keep us from accidentally bumbling into airspace. A lot of us are flying with transponders nowadays. Certainly microlight world, it's becoming the latest thing to have. So we're looking at controlled airspace, and the easiest way to work these is from the airfield. So let's put a bit of ground in here first of all, and then obviously an airfield. What we get, and we'll assume somewhere like East Midlands, where it's not all the way, we'll get a zone that's set up around the particular airfield, and this would be a CTA, or Controlled Terminal Area. In this depiction, this would be Class D airspace. What you would also get on a map, and I'll show you this, is an altitude where it starts from and where it goes to. So if it's touching the ground, you would get SFC, which is an easy one, surface. So that's its lower point. It always gives you the lower altitude first, and then it will give you the higher point, which would be 2,000 feet in this particular scenario. Now above that, that will be a CTR, control zone. Above that would where you would find the CTA. The CTA would be slightly larger. CTA, so control terminal area, control terminal zone, and again this would be classification of airspace, Class D, and it would be the altitude from and the altitude to. So in this scenario, the airspace starts at 2,000 feet and goes up to 4,500 feet. Now, certain areas may also have a TMA, Terminal Manoeuvring Area, and this would sit above the CTA, and the CTA would spread out. This tends to be Class A airspace, TMA, Class A airspace, and this would be 4,500 feet. And then once we sort of get around above the 5,000 mark is when it starts just switching to a flight level. So this might be flight level 5.5 plus, 5.5. Yeah. So 5,500 feet. Now above that, this is where you would get your airway. Now the airway would be given a depicting code, so let me just find one here. So we would give the name, like we have the M6 and we have the M1 and the M40, the airways, the motorways of the sky also are given a number. So let's use this one as an example, B29, and this would be flight level 5.5 up to flight level 195. So you can see that depending on where we are, now if we were to look down on this on plan view, it would look like the airspace was Class A airspace and a great big lump and we couldn't go anywhere. But certainly 2,000 feet, depending obviously where, we might find that we could sneak under that quite easily. So it's important that when you're looking at a map of airspace, that you take note, yes, obviously of what it is, but more importantly, what altitude it is. Certainly becoming more commonplace where people are bumbling into airspace through not being aware of their actual location. There's certainly plenty of stories out there where people have tried or they've followed flight software that's not been as accurate as they thought and they've flown into airspace. So yes, certainly being very aware of your location and certainly should you be in the loss procedure, you know to turn away from the airspace so you don't accidentally fly into somewhere that you don't. Why do we not want to fly in airspace? Because all this here would be Class G airspace and we are flying VFR, Visual Flight Rules. Visual Flight Rules definition is to avoid collisions, navigate by sight alone. When we start going into controlled airspace, there is a lot more IFR, Instrument Flight Rules, where you have aircraft that are solely relying on radio service and instruments in order to navigate and avoid collisions. And what's happening is you have the aircraft that are taking off from this airfield here, and what they want to do is get to the airway as quickly as possible. A terminal manoeuvring area, we might find that aircraft are coming into land, they might be put into a holding point before that they can come back into land. And so the airspace depends on the type of traffic that they get. And yes, an airfield will always argue that they need more airspace. What they're just trying to do is be relevant to the type of aircraft that are going into that particular area. Now, we also get some air traffic zones or that may be outside of controlled airspace. They may just be an airfield with an air traffic zone. Now, it's important that, and this is one mistake that a lot of people make, so let's bring in a picture. So let's have a look. Here is the land. Here is the airfield. There is an air traffic zone set up around that particular airfield, and it's an ATZ, and it will be controlled locally, more than likely by the airfield in which the air traffic zone is. Now, this ATZ has set figures. Bear with me, just to make sure I don't start talking about pressure. So the easiest one to remember is that this air traffic zone goes up from the surface 2,000 feet. Now the key there is from the surface up to 2,000 feet. Now that's not QNH, that's AGL, at ground level. So should this airfield be 450 feet, we would need to have a altimeter setting of 2,500 feet. You give yourself 50 feet, not much should you have an error on your altimeter. But again, we aren't flying over this airfield at 2,000 feet on our altimeter. It's plus the airfield's height above the sea, or altitude above the sea. So 2,450 feet. So that's an air traffic zone. We also, distance-wise, if the runway is less than 1,850 metres, it will be 2 nautical miles. So less than. If it's more than, then it would be 2.5 nautical miles. So again, you can look at the size of the ATZ and work out how big the runway is. Not that I'd need more than 1,850 in order to land. That's quite a big landing zone for us. Now we also get military airfield. Now, military airfields have a MATS, military air traffic zone, which extends out further than the ATZ within it. And the ATZ sets up a further zone around it. This would extend, I know it's not to scale, sorry. The ceiling of this would be 3,000 feet above the aerodrome. So it would be 3,000 and whatever the aerodrome is. I was once told a very useful thing on 54321. I always struggle on remembering this. There is a panhandle as well. And this, you'll probably hear the word panhandle mentioned, but this is a panhandle where the MATS extends further out, and not to scale, but this is 5 nautical miles long. If we were to put a depth on it as well, that is 4 nautical miles. Which one was the 2? So which means that this is 2,000 feet, leaving us a gap here of 1,000 feet.
2,000 and swap them over.
No, so 1,000 feet, that's 2,000 feet, and that's 1,000 feet. So 5, 4, 3, 2, 1. If that helps. These are normally 5 nautical miles from the centre of the longest runway as well. Now, the bit that's worth bearing in mind is that you don't actually need permission to fly through a MATS. It's strongly recommended because what's happening at military traffic zones? Any answers? Lots of people flying around in fast jets or very expensive helicopters that are either training or learning to fly or training to kill someone on the ground. So it's very important that although we can fly through this, I would certainly ask permission. The air traffic zone still falls under the normal rules in which we do need permission. Now, having transited, because we have a number of MATS in the areas that I fly, transiting through a MATS or a MATS penetration, they are more likely to send you here, over the centre of the airfield, than they are here or here, certainly here or here. So they are more likely to want to send you directly over the top of the airfield. And that's again because they have aircraft that are coming in to land in varying directions. So certainly if you're planning a cross-country route and you look to fly through a MATS or get a MATS penetration, that plan your route, that they are more than likely to ask you to deviate your course in order to fly over the centre of their airfield. It's also worth bearing in mind that when you're planning a cross-country, expect them to say no. And I have had that situation where I just wanted to nip through, I was at the altitude about 2.6, and just wanted to fly through the panhandle. Again, on reflection, probably a daft idea. And they said no, they are too busy, and they asked us to either climb or descend. And I think at the time I ended up climbing because it was a nice day. But always assume that, worst case scenario, that they're going to say no. You'll actually find the guys that work at the military air traffic zones very, very helpful. And any chance you get to speak to them would be a good thing to do. Now, there's also lots of information about prohibited, danger and restricted zones. Now, I'm not going to go into these in too much detail. It's very, very simple. You get two types, one that is a solid line and one that is a PET line. Is that okay? And you'll either get a P, D or an R. After that, you will then get a number which relates to that specific zone, and then you'll get a figure. So this is simple. P is prohibited. Can't go there. D is danger, you might not want to go there. And R is restricted, they don't want you to go there. Probably the easiest way of putting it. The number is relevant to the actual danger zone, so should you want to fly over there, you can look at the bottom of your map and either find a phone number or a frequency that you can tune into. But the more important one is this one here, and that is the altitude on QNH that prohibited, danger or restricted zone goes up to, and that is at sea level. So in this scenario, the airspace goes up to, or the prohibited zone goes up to 2,500 feet QNH. Okay? Now the difference between a solid line and a PET line meaning it is activated during via NOTAM. So those of you that are active on your NOTAMs, which are Notice to Airmen, might come onto this on another ground school, it will say that prohibited zone 407 is active, in which case you can't fly. Other than that, the solid lines are always active at the scheduled times. And again, they won't make it a secret. Depending on what part of the world, what part of the country you live in, you'll be a lot more aware of some of these prohibited, danger and restricted zones and why they're there. But these are the three. Work out which one. It doesn't really make a difference. They don't want you to go there or you don't want to be there. Identifying code, an altitude, and then whether it's active or whether it might not be active. So they're prohibited and restricted and danger zones. And again, if I can find the page, it's not a secret. So here we go. Lots of information on prohibited, danger and restricted zones. Very good book. Very good free book. Beauty about this is it's a PDF download. So it makes it free. It's issued by the CAA, which also means that when they change certain aspects of air law, this gets updated and you get to get another one for free. You can also buy I like a hard copy of most things, so you can also buy a hard copy. Okay, so that's about it for airspace. Again, there's a lot of airspace. I'm not going to go into the colours and the shapes. You can find that out very, very easily. But again, some of the more tricky things, some of the labels and things like that. Okay, has there been any questions?
Yeah, can I answer a couple of questions?
Yeah.
Yeah, one of the questions was, is there any ATCs not within Class D airspace? Yes, there is. If you take it was a question, is there any runways that exceed 1,850 metres that are not in Class D airspace? If you take somewhere like Llanbridge in Wales, which is an ex-military base, I think the runway is about 2,500 metres long, about 2.5 kilometres long, and that is not within any sort of restriction of airspace. It's got a air traffic control zone around it, and is now used for civil traffic. It's not military. Mats, can we fly in mats? Paragliders, gliders can fly in mats. Obviously, highly advised, do not fly within a mats. Okay. Also, when we look at airspace, something to be aware of. You can have ILS systems, instrument landing systems, that are depicted on an air map like this. It's like a V with a triangle like this. This depicts an instrument landing system being used at an airport. Now, normally ILS systems are within a terminal manoeuvring area, so you can't actually see them because they're coloured in. But ones that you can see, you must be very cautious of, because they will probe out of the ATC. Yeah, ATZ, air traffic control zone. They will probe out of them. Classic one is Coventry, near Usbos gliding, near the gliding centre. Yeah, if you're passing along here, you can be a long way outside this zone, but you're still passing. Be aware you are passing an instrument landing system. The pilot may be very busy thinking that he is in totally controlled airspace, and he's not. Is an airspace that we can use. My advice there is you move away and you move lower, because they will be on a glide path coming down into this. So the pilot will be quite busy at this point, so you're probably better off below it if you are going to pass. So it's something to be aware of when planning a cross-country flight. Don't matter what sort of aircraft you're on, is if you see that, just be aware. Yeah, and be aware it's there, and that you may get something coming at you at very high speed on the final approach. Okay? Okay, Mark?
That's okay. Okay, so another thing that we were asked when we put the question out this morning, what is it that you want? And again, we'll do this every now and again. You know, we could talk about varying topics and go into our usual routine, but sometimes there's things out there that people want to know. One of the things that came out was people who are currently, so this is students, people who are currently studying for their exams, and NAV is one of those complicated ones. You get an hour 30, an hour 45 or so to plan, and you've got to find the airfields. We went through that in long to show you how easy that was. You've got to do calculations for wind, variation, and there's a lot to go on. Now, when you look in the Cosgrove book, which is our handbook, there are 5 or 6 pages, and you know, it's I'm meant to learn all that. Yes, you are. One of the things that catches most people out, and again, we tend to do this anyway, is a simple equation called DST. Most probably are aware of this, but bear in mind that when it comes to the exam, you don't want to spend any time trying to remember on how to do certain aspects. So practicing. Again, one of the things we were touched on last time we did NAV was latitude and longitude, and everyone knows latitude and longitude. You'd be surprised, it's a lot harder, so practice finding airfields. And the other one is this DST, and most of us have done this. I've been driving for an hour and doing 60 miles an hour. I've got 60 miles to go, it's going to take me an hour, you know, so it's very, very simple things, and some people use this regularly, or some of us get lazy and type in the postcode and just follow the sat nav. So the equation to remember is DST. Very, very simple, basic algebra. If it's above the line, you divide. If it's next to each other, you times. Now, the thing to remember is that we need to keep the units the same. So the distance, when it comes to aviation, is in nautical miles. The speed is in knots. And the time is in hours. And so from this, if we wanted to work out a distance, so we wanted to know a distance. We know what speed we're travelling and we know how long we've been travelling for. What distance am I going to cover? So distance is very, very simple. We would times speed by time. If we wanted to know a speed, we would distance divided by time. And if we want to know a time, we would distance divided by speed. Now, again, remember that when you're dealing with time, and this is the one that most people get wrong, when you're dealing with time, it's in hours. So you might get an answer, and I'll keep this simple for my tiny brain. The answer will come out of 0.5. It's not 50 minutes, it's 30 minutes. It is 0.5 of an hour. And so therefore you need to be able to turn time into minutes, because on your exam it will ask you how long in minutes. It won't say in points of an hour. So an easy equation to remember is hours to minutes is hours times 60, and minutes to hours is hours divided by 60. And that way you can work out your hours into minutes. The other thing that people get wrong is this: speed. Most of us flex wing pilots, our airspeed indicator is in miles per hour, but our maps are in nautical miles. So we need to do a simple equation in order to convert miles per hour into knots. And the figure I want you to remember is 1.15. One mile is a longer distance than a knot. I used to remember this in a simple way. Sorry, a knot is longer than a mile. Yeah, it's 1 mile equals 1.15 nautical miles. I used to remember this, that my flex wing used to fly at 55 miles per hour, but my max speed was 47 knots. So whenever I was flying, obviously I was looking at the airspeed indicator, and again I was flying a blade at the time, so we pretty much did everything at 55. But when I was working out my navigation, my flight planning, I did everything at 47 knots. It's just, and so the easy one for me was Mark's plane flies at 55 and his map speed is 47. And the reason for this is very, very simple, in that miles an hour don't take into account the curvature of the Earth. Now, we've talked about latitude and longitude, and this is taken from the centre of the Earth out to the crust, and again, no flat world believers in us. So there we go. So 1 knot is the distance from here to there. So that's 1 knot. 1 mile an hour is the distance from here to there. So a similar sort of distance, but you can see that this one takes into account for the curvature of the Earth, where this one doesn't. It's a bit like mixing eggs and jelly. If your speed is in jelly, then the map should be in jelly. If your speed is in eggs, your map needs to keep the units the same. I use eggs and jelly because they're completely different. And although miles an hour and knots are speeds, miles an hour and knots are completely different. So it's important that you work that out. Certainly some fixed wing aircraft are also in miles an hour. So again, don't just rely on your computer software, work it out. Now, another thing that we get asked a lot on is T of E's, triangles of velocity. Now, triangle velocities, when you first read about them, seem the most complicated thing on the entire planet. Now, I've been able to narrow this down into about 10 points, but practice. What I want to do is give you a great way of practicing T of V's. So what are T of V's first of all? T of V's, triangles of velocity. Now velocity is very simple. It is a heading and a speed. It's not specific to anything, it's a heading and a speed. Now we should have been able to work out a number of these prior, before we've even factored in what we need to fly. So first thing we have is we have what we call track, and this is what we want to do. So Barry, give me a heading.
187.
Okay, so we want to fly 187. That's what we want to do. Andy, what speed are we doing?
47 knots.
47 knots. That's very useful. Fortunately, did it in knots and didn't do it in miles an hour. But you can see that this is our velocity. We also get given wind information. We know how to find the wind. So wind, Andy, where's the wind coming from?
Where's the wind coming from?
What direction?
Oh, 220.
So the wind's coming from 220. And Barry, what's the wind speed today? Keep it realistic.
12.
12. Okay.
Miles an hour.
We never get given in miles an hour when it's wind. So here we go. So we have what we want to do, what the wind's doing, and therefore we also need to do what is required. So in order we can work out these, you can see that triangle velocities, meaning 3, 1, 2, 3. Velocities, we got one, we got the other. We don't know this one. We need to do I say simple, we need to do a basic a way of working this out. The way I work this out, and again, you can see that this is on the cuff. I've asked Andy and I've asked Barry for very information, asked the dog, asked the TV, just pluck figures out of the sky, but keep it realistic to the aircraft that you fly. The very first thing that I do is I mark a starting point. We can also do an element of self-checking, but I'll come on to this as well. So first of all, put a starting point. So somewhere on a page, graph paper is quite useful. And I refer to this as a datum line, or I tend to use it as north. So with your protractor and your ruler, we can mark our north line on there. Here we go, north. The next thing that we want to do is add our track. This is what we want to do. So the track here is 187. We want to fly 187. So using the datum line we have, here we go, 187, using a big pen and a normal. Now the other issue that people have is that I'm using coloured pens, so you're going to be able to see hopefully the different colours, but you're going to be using probably one colour pen. So get used to marking the lines up. I think Cosgrove uses 2 lines, I'll use one on this one. And the next thing we need to do is mark the wind. And this is the first mistake that everybody makes, because the wind comes from 220. So imagine that you have a balloon, this is you have a balloon and you let that balloon go. Which way is it going to go? It's going to go from 220. So here is 220. Remember, we now have that balloon. The balloon is going to go that way. Now I can't help but mark wind with 3 arrows, it's just a lot easier to identify. The next thing that we need to do is invent a scale. Now if you're doing multiple T of E legs, you can use the same scale, but if you practice T of E's, you'll get used to your scale. The one I don't want you to use is a scale that's in the middle of the ruler. This is something that you'll have. This one gets quite difficult to see. And again, keep it big, so I'm going to use the 1/2 mil scale just to make life easier for you. Okay, so putting a scale on it here. So 0, 10, 20, 30, 40, 50, 60, 70, 80. Okay, so there we go, speeds. The first thing we're going to do is mark on the wind speed. So the wind speed we said is 12 knots. So using my ruler that I've just used, I can mark this on there. And the next thing we're going to do is mark on our airspeed. So we haven't had to do any equations yet, we're just marking it on the board. And this is 47 knots. This is the second mistake that everybody makes. So we're not going to measure from here down our track. We're going to assume that all the wind that's going to happen on this leg has happened straight away. This becomes our new starting point. So 47 knots, measuring from the wind line, and I'm going to make a mark there, where it intersects the track line. I'm going to join these two lines up. Maybe I should have doubled my scale so you can see it better. But you can see now that we have, in effect, a triangle. We have three sides. You okay? So we know that this line is the wind. We know that this line is our airspeed. So this line must be our ground speed. So using our ruler, and again if you've got a compass or a compi, you can measure the distance from here and compare it against your scale. Fortunately I use the ruler, so we'll go from here, and I can see that my ground speed is going to be 35 knots, just from measuring. And therefore, in order to fly this heading with this wind, using my ruler, now, depending on where it is, we need to take a bearing in relationship to the datum line, because that's what all our bearings have been taken from. So I'm just going to extend this down a little bit. In this scenario, that works for me. And the third mistake, don't measure the wrong end. Remember, we are going this way. One, 9, 6. So here's the scenario. We want to fly this, and we know that that's our airspeed. That will always be our airspeed, despite the wind coming from this direction at this speed. So taking these into equation, in order to do this, I've got to point in that direction. And my ground speed, more importantly, I'll be able to work out, is 35 knots. So when you're working out your DST, how long is it going to take me to get there, you've now got your ground speed. It's not your airspeed, it's your ground speed. Now, the only way that you'll become good at is by practicing TOVs. And again, we have colour pens in our navigation kit, but by inventing figures, you can practice. And it's the practice that means that when you sit down in your exam, it's dead easy. You're not just trying to remember what it is that either your instructor or Cosgrove has said. A number of self-checks that you can do to make life easy. 47 knots plus 12 knots is 59 knots. So call it 60. My ground speed is never going to be any more than 60 knots. Even with a full-on tailwind, that is going to be my maximum speed. So again, don't do a scale like I've done here up to 80, you're just wasting time. But it's a good checker, 60 knots. Another thing that we can do is a very simple fag packet drawing. We want to fly 190, so a simple line, we need to be particularly accurate. And we know that the wind is coming from 220. I haven't used a protractor, I haven't used any measurements, but I can see that I have a headwind. So my ground speed should be slower than my airspeed. So if you do this equation and your ground speed works out faster than your airspeed, you've got the wind in the wrong direction. Another thing on self-checking, if the wind's coming from this way, which way am I going to need to point? I'm going to need to point in this direction. So my heading should be more than my track. 187, 196. So before you do any of this, do yourself a very quick fag packet drawing and you'll be able to give yourself some self-checking. So I'm going to have a headwind and it's coming from my right, so therefore I need to be nose into wind. This way you don't get all the way through the end of your TOV, which can be quite painful, can be quite curing if you don't practice them. And you've now got an element of self-checking. Now, that's about it for me today. We could talk more and more. There's certainly 1 in 60 rule, the 10-degree method, and certainly the loss procedure that we can go into. We'll save that for another time, but I hope this particular one, and again, practicing things like DST, really will. And trust me, from being the other side of the desk, watching my students being nervous, you can tell the ones that have done their homework. You can tell the ones that have spent time. If you have an understanding school, which I'm pretty sure is 90 to 100% of schools, you'll be able to go to their classroom and just sit there and practice. Or you can wait till the kids have gone to bed and practice those TOVs, the 1 in 60 rules. Like I say, involve them, involve the cat, ask it for a number, it might give you a direction, or if it wanders off in a certain way. But you can just pluck figures out of the sky, keep them realistic. You can make up your track and your wind, and then just practice. A good way of checking is by going into things like Sky Demon, because it works all of this out for you. But here's a hint, you're not allowed Sky Demon in your nav exam. You might be able to use it on your qualifying cross-country, certainly as an aid. But again, from my experience, my battery has run out on me more times than I can remember, and I've had to resort back to TOVs. I mentioned to you about the whiz wheel, and I learnt for the whiz wheel for my PPLs. I end up throwing the whiz wheel away, and this is what I went back to, TOVs. Once you've got it, you'll never forget it. Clues: make sure you get the wind in the right direction, make sure you measure your airspeed from the right place, and give yourself some checks. Okay, that's about it for me today. Again, thank you guys all for watching.